This is an SQL speedrun from beginner to expert. When I say speedrun, it doesn't mean my explanation would be unclear. I will be walking you guys through every single concept with theoretical explanation and practical demonstration live with real SQL queries. And by the way, you guys will also get practical exercises along the way. And don't you worry, all the files including PowerPoint, demo queries, and answers for the exercises will be given in the link down below in the description. Let's begin the speedrun. To begin with, let me explain you the flow of this course. I separated these topics into sets, and at the end of every set of topics, there is a checkpoint, which means I explain the topics in the set, and right when I reach the checkpoint, I stop the theoretical explanation and I demonstrate the subject that we learned in this set of topics, which makes you feel connected to the explanation, because I don't want to explain, I don't want to show all the demonstration part at the end of the video, which makes it harder for you to follow up with the explanation. So I divided them into sets and checkpoints. And also I would recommend you guys to follow along by doing the demonstrations in your PC, so you won't get off the track and you will get some hands-on experience. Because this is a coding language, it is always better to have hands-on experience rather than theoretical knowledge. So I would recommend that. By the way, the files that I use in this course will be given to you with few links, and the links are in the description of this video. Everything. The PPT, it includes the PowerPoint presentation that you're looking at right now, and the SQL files for the demonstration that I'm going to show you. Everything will be in the links. To begin with, let's see what is a database. A database is an organized collection of data that is stored and managed so it can be easily accessed, updated, and analyzed. Just like a warehouse. In a warehouse, we store products, physical products, but this is a virtual warehouse, and this is a database where we store data. And according to the structure, the format of the storage that we use in this data, these databases are divided into two types. Relational Database Management System, which is known with an acronym RDBMS, and also known as SQL database. And there is another thing, the second one, which is Non-Relational Database Management System, which is also known as NoSQL database. Firstly, talking about RDBMS, like the name says, Relational Database Management System. This is a structured database where all the data will be segregated, separated according to the category that belongs to, and these categories are related accordingly. And this is a very structured and consistent. Whereas NoSQL is not structured whatsoever, but all the data is just dumped into one single collection or folder, whatever it is, and they don't have, the connections or a structure, a proper structure. But you might think RDBMS is a lot better than NoSQL, but they both have their own pros and cons. For RDBMS, the pros are it is structured. So we won't get lost in the data when we deal with a bigger system. When we have a lot of tables structured, we don't get lost because we already have the plan and the data is structured. So we can refer to the data following the structure. But in NoSQL, the data is not structured, so there is a very easy chance that you will get lost in the data. But the cons of RDBMS is it is hard to scale it. All right. If you have, let's say, if you have a few tables in the database, let's say you have a table for customer info, and there is a table for customer transactions, and you want to add a new kind of data, and that data is about customer subscriptional data, and you want to add this separate kind of data into your database. Then you have to categorize the data and you have to create a table for the data, and you have to relate this table to already structured database with a lot of tables, which is kind of hard. But whereas in NoSQL, you don't have that hustle. It is so easy to scale, and it is faster than RDBMS, but it is not structured. And the transactions are not, we don't have, in NoSQL, we don't have a good grip on the transactions that happens in the database. Whereas in RDBMS, you have a good grip. And example for RDBMS includes PostgreSQL, Microsoft SQL Server, Oracle, MySQL, and whereas in NoSQL, we have MongoDB, Cassandra, and a lot more. And the applications that we use for RDBMS includes banking system, where we concern more about the data and the transactions that we do rather than scaling the database. Whereas an example for NoSQL database would be an e-commerce database, where we concern more about scaling. Okay, that is the theoretical part of database. Now, why do I pick PostgreSQL rather than MySQL or any other SQL database server out there? Because this is the modern version of RDBMS, and it is completely free and open source. You can just download it right away and use it. And this is future-proof SQL engine for modern data workflows. So any data analyst or data engineer who is just getting into this is a modern data professional. This is the very best option to go with. Okay, now we have installation of the setup. We need PostgreSQL, which is our actual database, and we need DBeaver, which is the user interface for the database. We need to download these two, and you can download these two from the description or from the PPT itself. Let me show you how to download them. So in this slide, this is the link for the download. You just need to hold Control and click on it, and it redirects to this page. Choose the OS you use. Mine is Windows. I'm going to pick Windows. Click on Download the installer. Download the latest version. I already downloaded it, so I'm going to cancel it. And same with the DBeaver. Also download DBeaver. Click on the download link. And here for Windows, Mac OS, and Linux. I'm going to click on Windows installer, and the download starts right away. And I also have DBeaver on my PC. I'm going to cancel that. After you download, you'll see these two files. This is the PostgreSQL. Let's install PostgreSQL first. Specify the path or leave it default. I will leave all the settings as default and click on next. For the password, you have to remember the password because you have to use it. So use any password, but you have to remember that because you need to connect to the database with this password. So you have to remember that. Let's say the password, click next. Leave the port as is, or you can change it. It's up to you, but I'm going to leave it. Next. And it takes a few seconds to install. Now this is installed. You have to uncheck this. We don't need the stack builder, so uncheck this. Click on finish. Now install DBeaver in the same way. And leave all the settings as default. Click install. And click finish. Now we have Postgre and DBeaver installed in our PC, but we have to connect DBeaver to PostgreSQL. We don't connect by default, so we have to connect it manually for the first time. So you have to click on the button on the top left that says New Database Connection and choose PostgreSQL. Click Next. Leave all the settings default, and you have to check this box that says Show All Databases. Check that box, and for the password, you have to put in the password that you created when you install PostgreSQL. And with that, you will see PostgreSQL in this list of databases. And when you extend it, you should be able to see all these folders: databases, admin, and system info. That confirms the database is connected to DBeaver successfully. Well, our next topic is creating a database and schema. Before creating this, we have to know about the basic tree of the databases, right? Well, the foundation will be the server that hosts the databases, and these databases are the main containers which has the data in it. But the data is not just stored raw. The data is stored in the tables, and then these tables are structured using schemas, and then these schemas are stored in the databases. Like it says here, the tables that are stored, that stores the actual data, and the schemas are folder-like structure inside the databases. I said folder-like structure because the schemas act like folders in our PC or mobile phones, where we, organize our files with folders. Here we organize the tables with schemas. Okay, let's create a database and schema now. To create a database and schema, I'm going to split the screen into two. Right? So half of the screen is for the demonstration, and the rest of the half is for the theory. First, so this is the home page of DBeaver. This is our server, and inside the server, it hosts the databases. Right now, we haven't created any databases, but this database is created by default when we create the server. So we create our own database now. To create a database, we need to open an SQL editor. So right-click on the server name, click on SQL editor, open SQL script. Click on new script. Here, write, create database, e-commerce. Now let's talk about the basic principles of writing an SQL query. All right, any query should be ended with a semicolon. That is the indication of end of the transaction. When I say transaction, any query or set of queries are run in transactions in SQL. All right. So when you want to end the query, you have to indicate it with this column to end the query. And if you are familiar with SQL, you might have seen half of the query is written in uppercase and the other half written in lowercase. That happens because basically that doesn't even matter to the SQL, to the actual compiler, but we write them in uppercase and lowercase just for our readability. So even if I write this whole thing in lowercase, it still executes. It is the same for the compiler, but to read it, for us to make it easier for us, we separate them into uppercase and lowercase. So the basic rules are, we write the keywords in uppercase and the identifiers in lower cases. The keywords are the ones that are understandable to SQL compiler. In this case, create. SQL can understand create, and it can also understand database. So it can understand create and database. That's why we write that in uppercase. And there is e-commerce DB, which is an identifier that we are going to name a database. So an identifier can be in lowercase. It's for the readability. It can be in any case. It still converts everything into lowercase behind the scenes, the SQL compiler. But for the readability, we just write them in uppercase and lowercase. And if you run this, right, we can run it directly by clicking this. But if you have multiple queries written in one single notebook and you don't want all the queries to be executed, you have to select the particular query that you want to run and then hit run. So if you want to run this query, you just need to highlight it like this and then hit run. And you'll see the notification at the bottom. It says execution time. That confirms the query is successfully executed, which means you should be able to see the database listed. But you have to refresh the UI first. Click on the server name or the database name, right click and click refresh. That refreshes and you will see the new database that you created, e-commerce DB. And talking about uppercase and lowercase. If you want to name your database with a few uppercases in it, if you write it right away just like this, it won't create the database with this uppercase, because like I said, it converts the queries to lowercase behind the scenes, right? So if you don't want your identifiers to be converted to lowercase, you have to enclose that with double quotes on both the sides like this. Then if you run this will create a database actually with an uppercase. So if we refresh this, you'll see another database with an E uppercase. So right now I'm going to drop this because we don't need two databases. So this is a query to create a database. Now to create a schema, we write create schema e-commerce, and we cannot run this right away because our notebook is inside the Postgres database and not our database. So if you run this e-commerce schema will be created inside the Postgres database. To change that, you have to click the drop down and you have to select our database. Click on public, our database, and public. Now our database is selected. Now here, if you run this, it is executed. Now refresh, extend the schemas. We should be able to see the schema that we just created, e-commerce, and it should have all the folders listed. Now we have the database and schema. That's how we create them. Okay. Now for the theoretical part, we talk about the database objects. So the database objects are the structures that are created in the database to organize, manage, or retrieve data efficiently. And tables are structure of collection of data organized into rows and columns, and views behaves like table but does not store the data physically. We will see an example for each and every one of these topics, but right now you just need to know this theoretical knowledge. And there is indexes. Indexes specialized data structure that improves the speed of data retrieval operations on a table. Index table is just like an index that you can find in any of the books that we buy. So there is an index in the first page, right? The index acts like a guide for the desired chapter in the book. Here, the index acts like a guide for the tables. There is sequence. Sequence is a user-defined object designed to generate a series of unique numeric values in a specific order. For now, we're going to create a table, right? I'm going to show you how to create a table, but don't get confused of the keywords that I use here. We will be going through every single one of them. I'm going to explain everything. But for now, let me just write a query to create our first table. I have to change the schema also. Right now it is in the public schema. I have to change it to e-commerce schema before I run this, because I want to create the table in our schema that we created. E-commerce dot customers Now, I wrote this query. Like I said, don't get confused because I just wrote this query to show you how a table looks like. I'm going to run this. Because we have multiple queries, like I said, we have multiple queries in this SQL editor. So in order to run just one query, we have to select that, right? We have to select that and click run. So execute it. There you go. So this is how a table looks like. Right now it doesn't have any data. I just created a table to show you how. Oh, my bad. Run that again. How a table looked like. And these are the columns that I created: customer ID, first name, last name, email, and phone. So this is how a table looks like. It stores the data to itself, and you can see the table under the schema here. We need to refresh the schema first. Now, there you go. You can see the customers table created that we just created. Right? So the flow, the tree goes like the server, and the server hosts the database, which is e-commerce DB, and the database has the schema, which is e-commerce, and the schema has the table, which is customers. The customer has the data. The table has the data. And for the database objects, we're done. And the next one is tables, rows, and columns. A table is a structured collection of data organized in rows and columns. Columns are defined fields, and rows are actual records of entries. Yes, like I just explained it to you. Columns are defined fields. The fields that we have here are customer ID, first name, last name, email. And the rows, we haven't entered any rows yet. We will know about that, right? But to have the basic knowledge, rows are the records or entries, because a row consists, for a customer table, one single row consists of the customer information of one customer, one particular customer. And the second row includes all the information of the second customer. And that information is divided by columns using customer ID, first name, last name. Yes. To our next topic, PostgreSQL data types. Data types define which and what kind of data a column can store. All right. It defines what kind of data, what type of data can a column store. And for the text, there are 3 data types, which includes char and varchar text. Character stores a predefined length of data. The character is predefined, and anything beyond that limit, the character fails to store the data. Whereas varchar can dynamically change the limit. It is also predefined, but it can change the limit according to the input that it gets. But the maximum length of the varchar is 255. Anything beyond 255 cannot be held by varchar. And that is where text comes in. Text doesn't have any predefined length. It can hold any length, any sort of length. And they all have their own applications. For example, if you want to store an email ID, varchar will do. But if you want to store a review that a customer written, varchar will definitely fail, because a review can be of any length, right? It can be a very big string. So varchar fails to store that, whereas text can store it. But we should not use text for everything, because text takes a lot of memory, whereas varchar doesn't take that much of memory. So it depends. So we have to use them wisely to work with the memory efficiently. And then we have numeric data. Numeric data type includes int, big int, decimal, numeric, serial. Int is for the small integers, just like the whole numbers, and big int, not just whole numbers, by the way. Whole numbers, it includes all the integers, all the numbers. So integers are for the small numbers, and big int are for the big numbers. Decimal are for the decimal values, like 1.2 or 2.2, which has a point, decimal points. And the numeric data includes all the numbers. And serial is for the columns that goes on, that increments in each row. I will show you what serial does here, because we used serial in this table. We will see how serial works. And then we have date time. Date time has three data types. One is data, which only stores date, and the next one is time, which only stores time, and there is timestamp, which stores the combination of date and time. And Boolean data type only has two possible inputs. It should be either true or false. And JSON array. JSON is for the JSON string, JSONP is for JSON binary, array is for list. But the most used data types are these four. JSON and array is a very rarely used data type. And heading to the next slide. Before heading into the next slide, I'm going to show you how, how the serial works. All right. Right now, what data types we used in this table. This is how we create a table. Like I said, we use create table at the beginning, and we name the table, which is customers. Before naming the table, we have to define which schema the table should be created. And we create the table in e-commerce schema. So we say e-commerce dot customers, which is the table name. And we start with the parenthesis, open parenthesis. This is called as parenthesis, by the way. So we start with an open parenthesis, and we list all the columns inside the parenthesis. So the first column is customer ID. That will be the column name, the first column name, and that column is serial type, which is this one. The numeric data type, which is serial data. Oh, my bad. Serial numeric data type. We use serial there. And primary key. We'll talk about primary key later. But first, the next column is first name, which is of data type varchar. This one, varchar. And like I said, we predefine the length of the possible input there. And the length of this is 50. And the maximum length a varchar can hold is 255. Anything beyond that cannot be held by varchar. We use text for that, like I said. And we use varchar. Mostly we use varchar. We don't use character because it should be predefined. So varchar is a very varchar used very often. Then we have last name column. Last name is also varchar, which of length 50, and email is also varchar, but email is kind of long, right? Unlike the first name and last name, so we define the length as 100 here, and we talk about unique later. But yeah, the next one is phone. You might think, well, phone has numeric data. Why did we define it as varchar? Because only the columns that we use for mathematical operations should be defined in the numeric data types. But here we don't use that for mathematical data, right? Phone number is just like a serial number, just like an ID. So we don't do any mathematical operations. We don't add or subtract without the data inside that column. So we use varchar for phone, and we have city, which is also varchar, and the length is 50, and the state varchar 50, and created at. This is to store the time when the record is created, and the time data type is timestamp. which is under date time category. And the timestamp, like I said, it includes date and the time combined. We'll see about the default later and also the current stamp. But I'm going to tell you what current timestamp is, because it takes a lot of slides to finally reach that current timestamp function. Current timestamp function basically retrieves the current time. Let's say now the date is 6th of November. Is it November? Yeah. 6th of November 2025, and the time is 5:28 p.m. So that is what when we enter a record or when we give an entry to that table, it captures the current timestamp and assigns it to the created at. And we said default. We use default here. This keyword makes sure that create at won't go as null. Let's say if you want to enter the created at timestamp by your own while you enter the data in, so you can enter the data by yourself. But if you don't enter any data in that column, it takes this because it is the default. So it takes this. That's just a backup for the created at column. I hope you understand, but you will understand when we get to that part. But for now, this is the query that we use to create the table. And by the way, we wrote this query in multiple lines just because for the readability, but not the syntax. The syntax doesn't look like this, all right? This whole thing can be written in one single line and it still executes. You can just write this at like this with no multiple lines. You can just write define these columns right next to each other and in just one single line, and it still works. Like I said, if you want to say the compiler the query is ended, this is the only way you say it. You have to end it with a semicolon. If you don't have a semicolon, you can write the query in multiple lines. It still takes as one single query. But this is a lot easier to read than writing the whole query in one line because it is so lengthy. Yes, we created a table now. We know what are the data types in SQL. Heading to the next slide. Constraints and data integrity. Constraints make sure the data have some rules to enter into the column, right? So the rules for not null are ensures the column cannot have null value. Right now in this, we don't have any not nulls, but in a different table, we will use not null. So we just enter not null right next to this here. If we do this, if we use this, the compiler makes sure that the data entering into the table definitely has first name entered with some sort of value. It should not be empty. So it makes sure it is not null. So that's how we define the column. But for now, we don't need any not nulls in this table, so we take that out. And the unique. We use unique here for email, right? We use unique constraint to make sure every new record gets into the table. It does not match to the old records that is already stored in the column. And email should be unique for every single entry, right? Multiple person cannot register with the same email ID. So you use this constraint to preserve the uniqueness of that column. And we have primary key. Primary key uniquely identifies each record. And here the primary key is customer ID. when we insert the data into the table, if you want to refer, or if you want to retrieve a particular candidate inside the customer table, we can access to the candidate using the primary key, which is the customer ID. We don't go and search for first name, because there might be multiple records with the same first name, but customer ID cannot be repeated because it is a primary key. Primary key constrains that column to have unique entry for every record. So that is the best way to identify a row, and that's why we use primary key. And there is parent key. Parent key is used to link two separate tables. Now we created customers. We might create orders table to capture the orders that the customer actually makes. And to link these two tables, we use parent key by using this primary key, which is customer ID, inside the other table, which is orders. So we use this primary key in that table as parent key to connect these two tables. It might still sound confusing to you, but you will know when we get to it. All right, I will explain it to you when we create the data model. We will have the data model later, and then I will explain it. And there is check. Check validates a condition on data. SQL offers conditions where it gives output as true or false. Here we haven't used check anywhere here, but if we use check in future in any column, and if you want to check anything, let's say there is a column, let's say like price column. No, customer shouldn't have price. Age. Okay, let's say we entered a column as age and the data type as int. Oh, my bad. What am I doing? Int. All right. And here we can write a condition saying check of age is greater than 21. So we can write this condition here to make sure every customer that is getting entered into the table is an adult, is over 21 years old. That's how we use check constraint. But now we don't need it, so we'll take that out. Okay, next we have default. Like I said, we use default in created at. Default is just default creates a backup. If you haven't entered any data to that column, it takes the backup column, the backup data, which is the current timestamp. So it takes the current date and time in this case. Or else, let's say for the phone number, if we use default, give a random number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So if the record that is getting entered doesn't have any value in it, if it is empty, it will take this backup as the data for that. That is one of the constraints. Okay, next one, on delete cascade. Deletes child records automatically when the parent is deleted. I will demonstrate this in the when we reach checkpoint. All right, I will demonstrate that. Now let's skip data modeling. Now we need to, before creating a database, we have to model the data using we can draw it on a paper, or we can draw it in the PC using any software. For now I'm going to use Lucid Chats to model the data first. Data modeling is just planning our database. We need to have a plan before we create a database. So we're going to plan using data modeling. let's head to it. Like I said, I use Lucidchart. It is a free tool. You can also use it. I mean, it does have a pricing model, but you can create 3 documents for free. So it is a very good tool for data modeling. This is the home page. Here, you have to click on New to create a new Lucidchart and choose Lucidchart and create blank document. Click on the search bar in the shapes. Search for ERD. ERD stands for Entity Relationship Diagram. Entity Relationship Diagram is the most popular diagram to visualize a data model. We are going to use that. Drag a table here. Just left click on it, hold it, and drag it to blank. The blank board. And our first table, we already created that, which is customers. As customer ID. You can extend the column with that arrow by holding it. First name. Last name. So we write the column names in the middle section, and here we define the keys. You remember when we talked about primary key and foreign key, we define the keys on the left section, and the right section is for the data types of that column. Right now, the key should be empty. For the data type, customer ID, we used varchar. We use varchar for customer ID. Varchar. First name as well. First name is also varchar. But the primary key is customer ID. So we say PK. So we enter 3 column names. And for the 4th column, we don't have space. To create a space, you have to select the last column and then click on below right here. And this creates a new, a new row for a new column name. You can click on it multiple times. Well, we need 1, 2, 3, 4, 5, 6, 7, 8. So we need 8 columns. We already have 1, 2, 3, 4, 5, 6, 7. We need 1 more. So we add the columns like that. If you want to delete the column, we can delete it using this button. If you want to insert a new column on the top, if we click on the above here, and yes, basically we create it like that. Now let me just create all the tables we need, and then I'll be back. Now I created these 4 tables. The first one is for the customer info, and the second one is for orders, for the order info of that customer. We're basically creating a database for e-commerce website, e-commerce store. That's why it should. What are the basic tables that e-commerce store has? A customer info to capture all the customer info, and then there should be an orders table for orders info, and there should be products table for products info that are in the store, and there should be a category to categorize those products, right? That's why I created 4 tables. All right. In orders table, we use order ID, customer ID, product ID, and then quantity, order date. Here we used foreign key. Remember, we use, like I said, we use foreign key to connect 2 tables, and here we use customer ID as foreign key in orders to connect customers table to orders table. And then that is of int data type. And for the products, I have products ID and category ID. I used category ID as foreign key in products table to connect categories to products. Now, to relate these tables in the data model, we use something called notations, and there are a lot of notations, but the popular notation is crow's foot notation. The name crow's foot notation is derived because the notation looks like crow's foot, basically. And I'll show you why, right? You just need to click on this bubble, drag it, connect it to customer ID, right? And if you take a look at it, it looks like crow's foot, right? These 3 lines, and that's why the name crow's foot is derived from. And the relation between 2 tables can be shown with these symbols, and the symbols represent as, let me show you the symbols first. So these are the symbols. This symbol says 1, and this symbol says 1 and only 1, and this symbol says many, and this symbol says 1 or many, and this symbol says 0 or many. I will demonstrate what these relations has something to do with this notation. First, the relation between customers and orders would be 1 and only 1, 0 or many. So this is basically about to be particular, let me say. So what is the relation? I mean, in general English terms, what is the relation between e-commerce, the customers and the orders table? A customer can have many orders, right? But one order can be placed by only one customer. And that is what the relation says. One customer can have many orders. And like I said, this symbol represents 0 or many, right? And one customer can have many orders, or one customer can have 0 orders too. And that's why we represent the notation as 0 or many. And one order should and can only have one customer. And that's why we use 1, 1 as notation here. And the relation between products and orders will be here's the thing. One product can be in many orders, or one product can be in 0 orders too. Nobody might not order that product, right? So one product can be in 0 orders, or one product can be 1 or many orders. And that is represented with this symbol, 0 to many. And what is the relation for orders to products? It can be one order can have multiple products, right? And one order should have at least one product in it, or else order doesn't make sense, right? An order cannot have 0 products in it. It should have at least one product to many products. And that's why the relation goes like many or 1. And the relation between products and categories goes like this. So like 0 to many, both sides. One product can be in one or many categories, and one category can have 0 to many products. A category can be empty as well, so that's why I said 0, or else we can change the relation to 1 or many. That will work too in some cases. It's up to you. Just for your understanding, you just model the plan before you create the database. And this is our plan we just created. And these notations are to represent the relation between the tables. And these tables are the actual data and the columns that we're going to create with the data type, with the data types and the keys that we're going to define. Okay, I think we're clear with that. If you're not clear with data modeling is a big subject. It takes a dedicated video for itself. If you want, I can make one, but if you get it, that's fine. So this is the data model. Now I'm going to head back to DBeaver. DBeaver on one side in half of the screen, and PPT on the other side. Yep. Okay, our next topic is creating table and the queries that we use. Okay, these create table queries will be in a file, in an SQL file named create table queries. You can download it and run it in your database. So we initialize the foundation of the database first, and then we work on the examples, all right, the demonstrations. So I'm going to paste my queries here that I already written. And yes, we create the database, the data model, right? We keep the data model by our side here, and we write these queries actually. But because this is a speed run, I don't want to waste the time writing the queries in front of the camera. So I already have these queries written to create these tables, but I'm going to explain every single query that I'm going to run, right? For the first query, create table customers with the primary key customer ID, just like we defined in the data model, and the rest of the columns with varchar and created as timestamp with the default as current timestamp. And the next table is e-commerce products, this one. This one. And this one has product ID as primary key, right? And I haven't created the foreign key to demonstrate a keyword called alter in the next demonstration. So I wantedly did not create a foreign key in the products table, but we will create it in the next demonstration, all right? For now, we haven't created the foreign key. So the categories table is not related to products yet. Okay, this is the products table. Now I'm gonna run it. And then the orders table, which is this one, which has two foreign keys. We know how to define a primary key. We just need to write the column name and then the data type and then the constraint primary key. But for the foreign keys, it's a little bit different because we are referencing from another table, right? Here, to connect customer table to orders table, we use customer ID, like we defined here, customer ID, and the data type is integer. And because there is a parent key, we have to define the reference of that parent key. And the reference defined with this keyword, references, and the table that we are referencing from, and the column customer ID from that table, e-commerce.customers of customer ID. And at the end, we use on-delete cascade. Remember, on-delete cascade is also a constraint. Right here at the end, on-delete cascade. We used on-delete cascade for this foreign key, and we will see how it works, right? It basically, when we enter the data into these tables, on-delete cascade works like if you delete anything from the data that has this foreign key, if you delete any data in the parent table, the child table reflects that changes, Let's say, in this case, customer ID is defined with the constraint on delete cascade, right? And there is a customer ID defined in the customers table to reference two orders, right? And if we delete a customer ID from the customers table, which is also listed in orders, that customer ID will also be deleted from orders too. That's why we use onDelete cascade to reflect any data deletions from from the parent table to the child table. I will demonstrate it later, but for now, that's the definition for it. And let's run this table as well. We created that table as well, and then we create e-commerce categories, which has category ID and category name. Okay, we created the tables. If you refresh the tables, we should see all four of the tables, and they're all related accordingly to the data model. We're done with the data model with that. Now, inserting data into the tables. To insert the data, we use the keywords insert into, and the table that we are going to insert, and the columns that we are going to insert the data in. And we are inserting the data into customers first. Insert into, and the table name is customers, and the columns are first name, last name, email, phone, city, state. And then we say values, and then we give the values separated by commas. And at the end, we use semicolon to define the end of the query. Now, we're giving 6 records into, we're passing 6 records into this customers table. So let's run that. And same for the products table, we're inserting 4 columns, 4 records. Run that. And for the orders, we are inserting 6 records, and for the categories, 2 records. So I ran all those to make sure all the tables are created and the data in them are recorded. You can make sure using select all from whatever the table you want to check. I want to check categories first and the semicolon at the end. Run. See, we created the tables with columns, category ID and category name, and the data is also inserted into it. The data, electronics and home and kitchen. If you take a look at that, insert, I haven't inserted the custom category ID, but the category ID generated by itself because the data type of the category ID is serial. So a serial generates an integer that increments itself for every record, like I said. Same for the orders too. Orders, the order ID will increase sequentially for every record. So let's check on that table. We run that. See that? Order ID is generated automatically. I haven't given the input to it. Got generated. Yes. Now we have the tables. We have the data inside the tables, which is organized in the right way. So we're done with the initial foundation that we need. Heading to command categories. Command categories are of 4 types: DDL, DML, DCL, TCL. Firstly, talking about DDL. DDL stands for Data Definition Language, where we define and manage database structure. That includes the commands create, alter, drop, and truncate. We already used create a lot of times, right? We used create command to create database, create schema, create table. So we use create to create an object. It can be a table, a database, a schema, anything. And then there is alter. We use alter to, like the name says, to change the structure of already created object, the object that is already created. Let's say if the table is already created, we use alter to change the table, the structure of the table, not the data, the structure of the table after it is created. And then we have drop. We use drop to drop the table. Drop the table, drop the database. I mean, basically drop the object. When I say drop, it removes that object completely from the database. So we use drop to remove an object that is created. And then we use truncate. Truncate removes all the data inside a table. So if a table has, let's say 6 records, when we use truncate on that table, it removes all the data. It wipes off the whole data, but still the structure of the table remains. The table is still there. Table is not dropped, but the data is removed. Data is wiped off. So that's to wipe off a table, we use truncate. And then next category is DML, data manipulation language. This is more for manipulating the data inside the table. And we have select, insert, update, delete. Select is to select a specific set of data from a table. We will use it, all right? And insert is to insert the data inside the table. We already used insert, right? We used insert right here to insert the data into the tables with the values that we defined here. So we use insert command to insert the data into the table. And then we have update. We have update. We use update. Update is just like alter here. We use alter to change the structure of the table that is already created, whereas we use update to change the data that is already stored in the table. So we use update for that. And then we have delete. We use delete to delete the data that is already stored in the table. That is it. And then we have DCL, data control language. This is more like a theoretical part. We cannot demonstrate it when I'm the only user here, because this is implemented when we work with multiple people and we have a lead. So lead will have the admin access, and the lead will give the employees their permissions. So we use grant to grant the permissions to a particular employee, and revoke to revoke the permissions. So these are more like an enterprise grade commands. We cannot demonstrate it right now, but yeah, I'll show you all basic commands that we use for DCL. And for TCL, transactional control language, controls transactions, ensures consistency. This is one of the important topics you have to know. It contains commit, rollback, save point, and there is also save point. I think it's, yeah, I'll show you. There is commit, rollback, and save point. We will see the demonstration of these commands too. For now, let's switch. Our next topic is about transactions and ACID properties. Transactions, nothing but the TCL, transaction control language. We will look at it when we demonstrate, but for now, we'll take a look at ACID properties. The major difference between a relational database management system and a NoSQL database is ACID properties. Relational database has ACID properties. ACID stands for atomicity, A for atomicity, C for consistency, I for isolation, D for durability. Atomicity, all statements succeed or none do. So if you run a transaction, all the statements in the transaction will execute, or none of them will execute. Because we don't know about transactions yet, you just need to, we'll get back to this topic again, but for now you have to remember that. Then we have consistency, ensures the database remains valid before and after the transaction. Isolation, transactions do not interfere with each other. So if you open a transaction and your co-employee working on the same database open another transaction, both transaction doesn't interfere. If you're doing the same logic, let's say if you're doing the same logic of, you both are trying to update an age of the same customer, and you both open a transaction each, they won't interfere. One will get logged out and he will not be able to update it. So he should wait until you are done with your transaction. That is what isolation means. So RDBMS offers isolation too, and durability. Once committed, data survives, crashes, or restores. Once the data is committed, it just saves permanently. You have to know about transactions before knowing about atomicity, consistency, and durability. You will know about the transactions in the demonstration. We have to demonstrate the transactions, or else you will be confused. For now, skip. Then we have CRUD operations. CRUD stands for 4 core operations used to interact with and manage data in database: create, read, update, delete. We already used create. Create used to insert, create new table, create objects, and read used to retrieve existing data. Update used to modify existing data. Delete is used to remove the data. I mean, we already know about these operators. We already know about the commands. We already gone through these commands, right? But these are the important 4 core commands that you have to know specifically. So that's why we have this topic. Now, next, query demonstration. This is our checkpoint. Now we'll demonstrate everything that we just talked about. Okay, let's start with the commands. So first, let's go with the select command. I already used it, but if you haven't recognized this command, I'm going to use it again. Select star asterisk from e-commerce schema dot categories. Like I said, select is used to select a particular data from a table. But here I'm going to select everything from the table. For that we use asterisk. Asterisk represents all. So now this command says select all from this table. So it selects everything in the category table, which includes electronics and home and kitchen in category name, and category IDs 1 and 2. It selects everything and prints out. So we're done with select. So we're done with select. And we are done with the create as well, right? We don't have to worry about that. We also done with insert. And let's go with truncate first. Truncate. Truncate table e-commerce categories. Truncate deletes, wipe off the table. So it deletes everything, all the data from the table, but still the table still exists. But the data is wiped off. So when I run this and run select all from categories again, the table should be empty because I just wiped off everything from that table using truncate table, right? So we demonstrated truncate as well. To strike it out. Then, because we already deleted all the data, might as well drop the table, right? Just drop the table. While the truncate wipes off the data inside the table, drop totally removes the table from the database. So I'm removing the table totally from the database using drop table. I run that. It asks me, you are about to execute drop table statement, possible data loss. Are you sure? Click on OK. Now when you run this, you'll face an error. It says relation e-commerce.categories does not exist because the table is dropped off already. And if you refresh this table section, category is no more listed. Okay, that is how drop table works. Now let me create the categories table again, right? I just want to demonstrate it. So now the categories table is back again. Created it, and the data is also inserted. Okay, now we're done with drop table. And the next one, let's go with alter. Alter table, e-commerce schema, products, add column, category ID, references, and the reference is from e-commerce category. Column name is category ID. You remember we haven't defined category ID as a foreign key when we created the products. And I said we'll talk about it later, right? And these when we create the foreign key inside the products. Right now we don't have any foreign key here for the categories. To connect categories to products, we need a foreign key, but we haven't created any foreign key initially. But now we're going to use alter command to alter the table. Like I said, alter command is used to change the table that is already created. And here we're altering the table, e-commerce products, and we're altering using add command, add column. So we're adding a new column, which is named category ID and data type int, referencing from this table categories and this column category ID inside the categories table. So this is a foreign key inside the products table now. When I run this, that is executed. And if I print the products table now, we should be able to see the new column that we just added. Oh, I spelled it wrong. Products, sorry. Yep. The new column is category ID. We just created that column and it is listed there. But right now it is null because we haven't assigned any data to that column, right? Okay. We created the column using alter table, which means we're done with the alter command too. Let's head to update. Update e-commerce dot products set category ID equals 1, where category equals electronics. Okay. Run that. Okay, what is that? Oh, the same error. Spelled it wrong. Now what I did here is I used update. You know, update is used to update a data, a table's data after it is update is used to update the data that is already stored in the table. And here we're updating the data where we're saying it to set category ID equals 1, where category equals electronics. We haven't talked about where yet, but just, basic English. We're just saying that to set category ID equals to 1, where the category equals electronics. Before running this, we saw the category ID as null for all the records, right? But for now, we change those records where category is electronics, the category ID is 1. We updated the data. So wherever the category is electronics, the category ID is 1. Now we're done with update. Wait, you might not see because my face cam might blocking it. My face cam might be blocking it, so I'm going to extend that output. Now you can see, right? You can see the category IDs are assigned. They are not null anymore. I mean, these both are null because the category here is home and kitchen. We just updated the category electronics with category ID as 1 for products table. Yes, okay, we're done with that. And the next one is delete. To demonstrate delete. Delete is used to delete a particular record or a chosen set of records. Here we're deleting one record. So deleting, I mean, not one record, but deleting from e-commerce customers where customer ID equals 1. So any column with customer ID equals 1 will be deleted. Before executing it, let's have a look at the customers table first. Well, this is the customers table now. It has 6 customers right now, right? And when we execute this and run this again, now we just have 5 customers because we just deleted the customer with customer ID 1. With that, we demonstrated delete. Yes. I said I'm going to give you a few examples for grant and revoke permissions, right? This DCL data control language. To grant a permission, you say grant select and insert on right here, this query. So this is a basic syntax of the grant permission query. We are granting select and insert permissions of the database or the table here. For the products table, we're just granting select and insert permissions to this user. So grant select insert on this particular table to this user. This is the syntax. Grant select, grant and the set of permissions, and on which table or database, and to which user. This is the basic syntax. And when you gave the permission, if you want to revoke it, if you want to take the permissions out of that user, you can use revoke. Use revoke insert on this table from analyst user. We granted select and insert permissions for the table, and we revoked insert permission. So now that particular analyst user only have select permission on that table. I mean, like I said, we cannot demonstrate it here because that is something related to multiple users, so we cannot do that here. But yes, that is a syntax. TCL, Transaction Control Language. You have to understand this, all right? I'll try my best to explain, by the way. So, every time you run something, a query, a transaction gets started and committed behind the scenes. You won't see that on the screen. You just see you running this query just by selecting it and hitting the run. But behind the scenes, what happens is the compiler runs this. It runs begin. It runs begin. So begin is the keyword to start a transaction. So it starts a transaction using begin, and then it saves the transaction using commit. Right? So when you run this query right away, behind the scene, compiler runs this. It begins a transaction and it runs the query and it commits the transaction. If you start a transaction, if you begin a transaction, and if you do not commit the transaction, the changes will not reflect on the database permanently. You have to commit it. This is what happens behind the scene. But if you want to have full control on the transaction, you yourself start a transaction. And I'm going to show you how. To start a transaction, like I said, we use begin. All right. So begin, when you run begin, you're starting a transaction. Okay. And right now, what is our products table? I'm going to run this in a separate new tab. So to run anything in a new tab, you have to click this one, all right? We click that. So it runs in, it executes in a new tab, not in this one. So it executes in a new tab. Right now, our product's price is $12.99, $25.99, right? Okay, now we begin the transaction. We run update e-commerce schema dot products and set price equals price times 1.1, where no, I'm not gonna use any where. All right, so this is a query. We usually run this query right away, like any of these other queries, right? But here we started a transaction. All right, we started a transaction, and when we run this, it asks for this. Click OK. When we run this, it executes. We can actually see that. Let me run that in a new tab. We can actually see the changes with that particular query, right? Initially, this was our prices, $12.99, $25.99. Because we multiplied the prices in times 1.1, these are the updated prices, $14.29, $28.59. But these are not permanent, all right? These changes turns permanent only when we commit. But if we do rollback, okay, if we do rollback before committing the changes, whatever we done in this transaction will be redone, right? Just like the redo button we use, all the changes that we've done in this transaction since the begin, we just done this query, right? This will be redone. Now, because we used redo, now the products table will be changed back to normal, which has $12.99 and $25.99 as price. That is how transactions work. You might feel useless to use this transaction, but when we work with a big transaction like which has a lot of queries, this is a lot useful. Let me show you a small example of save point now. Save point price increment. Now the transaction is ended, so I have to create another transaction to demonstrate this. So I'm going to create another transaction. So this is our initial product table, right? And I'm going to begin a new transaction. Begin, and then I run this query. Okay. Now it should update the product table. Now I'm going to run this in a new tab. So now the prices are changed, but they're not committed yet. We can roll back the changes. But if we run save point, all right, this tab, if we run a save point is like a checkpoint in the transaction. Here we put a checkpoint after this query. And now if I run another query after the checkpoint here, right, we run this again after the checkpoint. And now if I print the products, now this will increment the price again from $4.29. Initially it was $12.99, right? And in the first part of the transaction we incremented it to $14.29, and the second part we incremented it to $15.72. But the checkpoint is after the first increment, after this one, right? We have a checkpoint after that. Now if you want to roll back to that checkpoint, which means you want back these prices to be permanent and not these latest ones. You only want to increment it once and not the second one. You can roll back to that checkpoint using rollback save point, rollback to save point, sorry. And the save point name is price increment. Okay. But if you run rollback, both the changes will be rolled back. They will be redone. But if you want to roll back to the save point, you have to mention the save point and roll back. Now we run this. Okay. So remember, this is our initial price, $12.99, and this is our first increment, $14.29, and this is our second increment, $15.79. Now if I run the products table again, in a new tab. Now this is a permanent change that made. Roll back to the save point and makes the changes permanent. And now instead of 1572, because we rolled back, so only one increment is made permanent, and that is 1492, and this is our final table, 1492. That's how the transactions work. And now I shown you the commit, rollback, and save point, right? With that is done. I hope you got this the transaction part correct. I just gave you a basic command already, right? The select all from e-commerce categories that we just used. But there is a lot more to explore in select command. It is a widely used command when you use SQL. So we have to learn a lot about this. Select retrieves data from one or more tables, allows you to filter, sort, aggregate, and analyze it. And this is the basic syntax of select. Select can select one or two particular columns in a table. Using select column 1 or column 2. Instead of using asterisk to select everything, you can just select particular columns from tables. And we use from table name, like we used here, from table name, and we can include where clause. We can combine where clause with it to use conditions, and we can group by. We can use having condition. We can use order by, ascending or descending. So we can order the result with this ascending or descending order, and we can limit the number of outputs. Our first concept is about where, because where condition goes at the top of the select, right? And where clause can have conditions in it. So where is used to filter rows from a table before any grouping or aggregation happens. So, and these filters use operators to filter the data. The operators specified into comparison operators, range operators, search operators, membership operators, logical operators. Comparison operators includes equal to and not equal to, greater than or less than, greater or equal, or less or equal. These are all the comparison operators. We will see example for every single operator right now. And then we have range, between, and with range, with between we can select a range of outputs. And then we have like to search, and these are the examples for them, by the way. We have all these operators, and for the membership we have in or not in, and for the logical we have and or not. Order by, limit, fetch, clause, because that is our next thing to know, because we already used having condition as well, right? No, we haven't used it yet, but yeah, we will talk about having at the end of the slide, at the last slide of the checkpoint. But for now, we go to order by, limit, and fetch. Order by clause sorts the result set of a query based on one or more columns. It just sorts the result. Then we have limit. It limits the number of outputs we get. Fetch is same like the limit, but it doesn't have offset in it. We'll see examples for everything, like I said. Aggregate function performs calculation across multiple rows and returns single value. And aggregate function includes count of, which counts the given the data that is coming out. So it counts the total number of number of rows, and sum adds up the numeric values. Average calculates average. Minimum finds the smallest value of a given set. Max finds the largest value of the given set. We have group by and having. Group by groups rows that shares a common value into summary rows. And having filters those group results like where. The syntax is like this, right? We have to use where before group by. But if you want to use where after group by, we have to use having. So having works like a where, but after the group by. Like it says here, having filters these grouped values, the values that are grouped. So if you want to use where after on the grouped values, the only way you can use that is by using having. You cannot use where after group by. Where should be used before group by. But if group by is already added and you want to use where after the group by, you have to use having. And this is the syntax for that. You have to use group by and then having condition. Now the checkpoint. Now we'll create a new script. I'm going to create a new editor. Open SQL script, new script. First, let's start with basic select command, which is select all from products By the way, if you don't want to write this e-commerce every time you run the command, you don't want to write the schema name, you can just change the location of the notebook to this schema e-commerce, and you don't have to write this schema name anymore. You can just run the products directly, the table names directly. That is the basic select command, right? We already know about it. It just prints the whole table. Now, new command, select, just one column is product name, and category from products. Use where clause, and for the first condition, we go with in stock. For the first condition, we used the first operator equals to, okay, and we use where clause. Now it selects product name and category from products table where in stock equals true, because in stock is a Boolean data type, remember, and this is the in stock table, and here the first one is in stock and the second one is not in stock, and the third and fourth are in stock. So when we filter this, filter it with this expression, with this query, only the rows that has in stock as true will be printed, which means we should be seeing the product names: coffee mug, wireless mouse, Bluetooth headphones. So let's see. Let's run that. See, coffee mug, wireless mouse, Bluetooth headphones. I'm going to open the actual products table in a separate tab just to compare. This is the actual table. It has 4 products, but the filtered one has 3 products which are in stock. Okay, now for the next demonstration, our next operators are not equal to. We can just change this to not equal to. Not equal to has 2 symbols. It can be either this, which has it can be this symbol, or it can be less than or greater than combined. So first let's run this. So which means this is opposite to this table. Now it prints the only product that is not in stock, which is desk lamp. We can also use this symbol. Let's try the other symbol. Same output. Okay, done with that. Now let's write another query to demonstrate this: less than or equal to, less than or greater than. For that, we cannot use in stock. Let's use price. Price less than $15. I mean, less than 15. Which products are less than 15? The one on the one on the top, coffee mug and desk lamp. So these 2 products should be printed when we run that. So let's see. Coffee mug and desk lamp. Coffee mug and desk lamp, which has the price less than 15. And if we use greater than, that is quite opposite to less than. This should be changed. Wireless mouse and Bluetooth headphones. Yes. We can use the same example for less than or equal to, right? You can use less than or equal to. Less than or equal to let's say 25.99. Now this should print the wireless mouse as well, because it is equal to that, right? The price is equal to 2. Oh shit. Yeah, the price is equal to 25.99 for the wireless mouse. So it printed all the three. And the less than or equal to is quite opposite, so we don't need to demonstrate that. So we're done with the comparison operators. We're done with these, and then we have step. Just strike out comparison. We have now we have range. Let's write an example for that. Select. I'm going to use the same example, but in the where I'm going to change it to I'm going to change the operator to between 25. Now let's say between 10 to 30 should be good. 10 and 30. Now this filters out the products that has price in between 10 to 30. And what are the products? This one, coffee mug with 12.99 and wireless mouse with 25.99. That should be the output. There you go. Okay, now with that, the bit feed is done. And then now search. I'm going to copy the same thing, but here I'm going to use product name instead. Product name. Right. I'm going to say percentage. Run this. Percentage MUG. And run this. Coffee mug. So it selects. It searches with the pattern matching. Like it says, it searches with the pattern matching. So the pattern inside the product name should match this. And the percentage indicates anything can be before this pattern mug, but there should be nothing after the mug. Here in coffee, there is coffee before the mug, but after the mug, there is nothing, right? So the pattern matched with coffee mug, and coffee mug got printed. And if you want to use percentage at the end, you can use it like this: COF and percentage. And the pattern should match. There should be nothing before COF, but there can be anything after COF, because the percentage is after COF. And this will print the coffee mug again. And there is another type for the pattern matching, which is, let's take a different example now, which has percentage on both sides, like this. So there can be anything before less, there can be anything after less. So just match less, which prints wireless mouse, because there is wire before less and there is mouse after less, but it just matches the pattern. Okay, we're done with that. So we're done with the search operator. Now the membership operator, something like this, but product name in a list of objects. So it should, I'm going to select coffee mug, can be coffee mug, a random object. I'm going to name phone, wireless mouse. Now we're telling SQL to select product name and category from products where product name is in one of these objects. It can be coffee mug or phone or wireless mouse, which means we don't have phone in the table, so we have coffee mug and wireless mouse, and those two will be printed. Let's run that. Something went wrong. What is that? Syntax. Oh, that should be comma. Okay, let's run that again. Coffee mug and wireless mouse. We're done with the membership, and the next one is logical. I'm going to use this one. Price less than 15 and product name let's say not equal to coffee mug. So we're saying SQL to select product name and category where price is less than 15 and product name is not equal to mug, coffee mug. So both these conditions to be satisfied for that particular row to be qualified. Okay, it should be less than 15 and it shouldn't be named coffee mug. So what is less than 15? These two, coffee mug and desk lamp. But because it should not be equal to coffee mug, the product name, coffee mug will be taken out. Only desk lamp will be printed. So let's run this and see if it works. Desk lamp. And that's an example for and an example for or. Is or select wireless mouse. Now, in AND, both the conditions should be satisfied to qualify that particular row. But here, any one of these conditions should be satisfied to qualify that column. For now, for the first condition is price should be less than 15. So the coffee mug and desk lamp will be qualified because the price is less than 15. And the product name should be equal to wireless mouse, which is this one. So these three should be printed. There you go. That's it. And for not, that is simple. We already know this will print coffee mug and desk lamp, right? Because they both are the one that has the price less than 15. But if you want to make it opposite, which means by adding not, it is quite opposite to these two. The products that are not less than 15 will be printed. That's it. Okay, with that, we're done with the operators. Now, moving on, we have order by, limit and fetch. Okay, for the limit, for the order, we just copied the same thing, but I'm going to take the not out. I'm going to increase it to 30. The syntax should be select from order by limit. You can also use where. So after where, I'm going to use order by price DESC, descending. Now if I run this, Now, we're saying SQL to select the product name and category from products where price is less than 30, which means it selects wireless mouse, desk lamp, and coffee mug. But we also said SQL to order them in descending order, to print them in descending order, which means wireless mouse should be at the top because that has the highest price, followed by coffee mug, and then desk lamp at the end. That is what we got. If we say nothing in the order by default, it takes ascending order, by the way. Just to let you know. So by default, it takes ascending order, which is desk lamp with $0, coffee mug with $15, and wireless mouse with $26. By default, it takes ascending. Now let's say descending. Okay. So we're done with orders, right? Order by. Now we see limit. Limit 2. Now the results will limit by 2. Just 2 results will be printed now. Let's run that. There you go. And these are will limit the output. But there is another thing, offset, right? Offset, and let's say 1. Offset says the limit where to start the count. Okay, when I say offset equals 1, it starts from the first column and then it counts 2 and prints that. All right, let me try to explain it more clear. Okay, now this is what it prints without the limit, right? When we say offset equals 1, the count of the limit starts from the first one, and it don't print this one. It counts the next and the next 2, which is coffee mug and desk lamp. Now when we run this, only the coffee mug and desk lamp will be printed and not the first 2. The offset determines when to start the limit count, basically. That is that. And then we have fetch. Works like the same. It works same like limit, but it doesn't have offset. Let's write fetch first 2 rows only. Now, instead of these 3, it only fetches the first 2 rows, wireless mouse and coffee mug. There you go. That's how fetch works. We're done with fetch and limit. And our next concept is aggregated functions. We'll see examples for every one of those aggregated functions. So let's go with the first one. Select count of product ID products. Now I'm just selecting the count of product IDs from the table products. I'm just selecting the count of them. So it just counts the product ID. Right now there are 4 product IDs, this column. Now right now there are just 4 product IDs. So it prints 4, output as 4. 4. So that is our first aggregated function, and then we have sum. Select sum of price from products. All right. This will sum all the prices from the products table, which means it adds up all these prices and gives one result, which is 118.48. Okay, and the next one is average. Works same like sum, but it gives the average, AVG. Now it gives the average of the price, 29.62. Next one is minimum. I'm going to use the same example. It gives the lowest value. That's it. 0, which is 0, because we have 0 for desk lamp. So it prints 0. And the max prints the maximum in the prices. $79, which is this one, Bluetooth headphones. Okay, we're done with all the aggregated functions with that. And moving on, have group by and having class. Okay, let's see an example for those two. Select category, sum of price as total products group by category There you go. Now, so these are our actual table, right? With this, we're saying SQL, select the category and sum of prices as total. This one is a new keyword for us, right? We use as to alias a particular object with a different name. Here, we are calling sum of price as total. So when the result is printed, it is printed as total. That's why we alias it with total here. Just a desired name, you know, I mean, a name that we define. If you don't use as here, it just prints sum of price as the name of that column. So it's better to give a name to that column. So we use as total to give a name to that column. So we're selecting category and sum of price from products, and we are grouping them by category. And the definition says group rows that shares a common value in summary rows. And the common values in the categories are home kitchen, which has 2 columns in common, and electronics, which has 2 columns in 2 rows in common. So these two will be grouped together. Home kitchen, these 2 rows which has home kitchen will be grouped together, and the price will be summed together, which will be the result as $12.99, because this is 0. If you sum 0 with $12.99, the result will be $12.99. And for the electronics, these two are the same category, so these two will be grouped and the price will be summed, $25.99 plus 27.5, and the result is already here. This is the result. And I want to say to you guys a basic rule of thumb in SQL when we use group by is when we use group by in a query, if anything that you select here, any column that you select here, it should be either in the group by or it should be aggregated. Here we selected 2 columns, right? So each of the column, at least it should be in group by or it should be aggregated. Here the category is in the group by. So the other one, price, should either be in group by or should be aggregated. Here we aggregated it using sum. And as we know, aggregation turns a set of values into one value. So that is the basic rule of thumb. When we use group by, the select, any column in the select should be either in group by or should be aggregated. Okay, with that we're done with group by, and we'll use the same example for having too. Like I said, having is nothing but when, but we use having after we use group by. After we group, the rows, then we can filter from that rows, the grouped rows, using having. We cannot use where here. Funny. Now this filters out one column, which is a 1299. So these nothing but where, but for the rows that are filtered, that are grouped, not filtered, that are grouped. Now we only print electronics now. Electronics 105.49. That's how having works. With that, we're done with that too. Done with the demonstration as well. Next topic is null and coalesce. Null represents missing or unknown data in SQL. Yeah, right. And coalesce returns the first non-null value from its arguments. And I'll demonstrate that right now. I'll demonstrate it right now. Okay, and the next one we have is null if. Returns null if both expressions are equal. I'm going to show you an example for each and every one of them. First, let's do select all from. Let's change this to e-commerce. Products. These are our products table. We all know that. For the first example for null, product name, e-commerce, where category ID equals is, sorry, we cannot use equal here because equal is a comparison operator. It can only be used with the numeric values and not the strings. Now if you run this, read e-commerce products here. We run this. If we are selecting the product name from products table where category ID is null. Which are they? Which includes the category ID. These two have null as category IDs. And those two products are coffee mug and desk lamp. If we run this, those two will be printed, coffee mug and desk lamp. And an example for, and not null is quite opposite to it, but I'm going to run that as well, just for the demonstration. Quite opposite, right? The next example, select product name, COALESCE, category ID, comma 0. At ID e-commerce. You don't need e-commerce products, it's fine. Products. Like I said, like the definition says, COALESCE returns the first non-null value from its arguments, and the arguments we are passing here is category ID and 0. By the way, 0 is not null. Null represents nothing, but 0 is something. So 0 is a not null. So if category ID is null for any row, it immediately, it doesn't, it is not valid for COALESCE, and it returns 0. So yes, when we run this, you see, it won't print null, it prints 0 instead. But if we run just the category ID without using COALESCE, this is different. This prints null, right? There's nothing in these two fields. But if we use COALESCE, it represents with something that we want. Here I said 0, but we can replace it with anything, literally. We can replace it with 100, and it takes it. So if we run this, it replaces the null with 100 here. So it takes the first non-null value inside the given arguments in COALESCE. That's how the COALESCE works. Okay, we're done with that. For the next example, for the null if, we have null if name here, we're trying to avoid the 0 division error. If you don't use null if, this expression doesn't make sense to use in this context, but just for the testing purpose, we're going to use this, all right? So if you don't use null if here, this will pop an error. Let me show you the error first, and then we run this actual query. So without null if I just do price here, division by 0 error, right here it says. So we cannot divide anything by 0, right? So instead, we can use this, all right? We use null if, and null if checks, like it says, it returns null if both expressions are equal. And the expressions inside are price and 0. Well, the price and 0 are equal, right? For this column, for this field, price and 0 will be equal at this part. So it represents null instead of 0. So it avoids division by 0 error. Now if I run this, it just represents it, replaces it with null instead of getting that 0 division error. That's how we use it. Next one, conditional logic. Lets you apply if, then, else style decision making directly inside your queries. If you used any programming languages, there is something like if, then, else statements. If statements in Python. If you ever learned any language like Python, if you would see the if condition, and it says if this, execute this, or else execute that. So case when gives you, lets you apply something similar to if conditions in SQL. Let me show you an example for that. Wait. Case then 1 equals home and kitchen, then 2 0. If the category is not found, don't leave it null. Instead, replace it with 0. Okay. Here we're not using select here. We're using update products. And right now, the category ID for these two is null, right? For the home and kitchen is null right now. But we can replace that null with 2 for home and kitchen. And that's why we're using this. Update products. Update the products table, set category ID equals, and then it starts case. Case, we use case to start a case, and inside the case, when category equals electronics, where here the category equals electronics, then 1. So the category ID will be 1. For electronics, category ID will be 1. When category equals home and kitchen, like as in this 2 rows, so if the category equals home and kitchen, then replace category ID, update the category ID as 2. Right now it is null. When we run this condition, when we run this query, this should update these category IDs to 2. So if any other condition, if the category is any other category other than these two, update it with 0 and end the case. So the case should be ended at the end. When we write the case, it should be ended at the end, or else it won't execute. So let's run this. Okay. So it is taking a long time. Let's make it easier for that, for the compiler, by adding a where clause at the end. Say where category in or home and kitchen. Just making it easier for the compiler to run this. To run this shouldn't take much longer. It did execute it, but we don't even need the where clause at the end, by the way. I just ran this query, still executed, by the way. I just restarted the DBeaver because I kept the DBeaver open so long. I think it got some sort of a glitch. So I restarted the DBeaver. Now it ran. And now when we print the products table, it should be, the category ID should be filled with 2, 2, and 1, 1. The nulls are filled. So with that, we're done with case as well. Next one, string, numeric, and date functions. SQL functions are built-in operations that manipulate, transform, or calculate data. First, we have string functions, and then we have numeric functions, and then we go to date functions. Okay. First, for the string functions, we have lower of, converts text to lowercase, and upper of converts text to uppercase, and uncat joins two or more strings. Substring extracts a part of a string, and length returns the length of a string, and replaces a substring with another. Okay, now let's see an example and the demonstration for every single one of these string functions, starting with the lower. For this demonstration, let's choose the customers table instead, not the products. Because customers have more names, because it captures the customer names, right? That's why. Okay. The first example, lower of first name from customers. Here, if we don't use lower of first name, the first name would have K as uppercase, because here it's stored as K as uppercase here. But when we use lower of, it converts every uppercase in that string to lowercase. So when we run this now, it prints everything in lowercase, even the K in the Kate, R in the Raj, and L in the Liam, and S in the Sophia, N in the Nova. All of them are capitals or uppercase in the actual table, but we selected them with lowering the cases. And the upper of is quite opposite. I don't think we have to demonstrate, but I'm going to demonstrate it anyway. Okay. Upper of. Now if I run that, every lowercase turns to uppercase. You see that? That's how it works. And the next example, select concat first comma. I'm going to give a space in between and last name from customers. Now, this selects the first name and the last name and concatenates them, which means joins two or more strings. So it joins it. And here I'm passing 3 strings, by the way. One is the first name string, and I'm passing just a space string and a last name string. So it combines everything into one. Let's run that. You see that? So the first name and last name both are joined, and the space in between is also joined with them. That's how concat works. Okay, now I'm done with lowercase, uppercase, concat. There's substring. For the substring, let's select substring of class name from for 3. From customers. Now, what this does is, let me run that first. So what this does is, just like you remember when we talked about the limit and offset here, this is something similar to that. It only selects a part of the string, the last name, and it starts the count from 2. This is the offset from 2 for 3. So it starts counting 3 from the 2. Let me explain you clearly. All right. So the first output is HOM, right? Because in the last name it selected from Thompson, it started counting from 2, which is H. So from H, it counted 0 O M P. Sorry. So it started from H O M, where H is the second alphabet in the string. So it started from H and counted 3, H O M, and printed that. 2 is the offset and 3 is the count from 2 for 3. Something similar to limit and offset. Substring is done, and for the length, select length of, it just prints the length of that string. And here we're selecting the first name as a string from customers. So it only prints the length of that string, 43464. So the first name is Kate, which is 4 strings, and the second one is Raj, which is 3 strings. Yes, that's how it works. And then we have replace. It replaces a substring with another. Example for that would be, I'm going to select city. Angeles with Santa's customers. Now, in the customers table, we have city column, which has all the city names, right? And here I said replace in the column city, replace Angeles with Santos. Now, when it prints the city name Los Angeles, it prints Santos instead, Los Santos instead of Los Angeles. So it replaces the Angeles with Santos. So let's run that and see if it works. See that? Los Santos. So whichever city that has Angeles in it will be replaced with Santos. That's how replace works. That replace is also done. Now, the next function are numeric functions, which has round off, seal off. Round off rounds a number to an n decimal places. Seal rounds up or rounds down. ABS stands for absolute. Absolute returns absolute value. Power raises to a power. Random generates a random numbers. Example for that is, I'm going to say 2, 3, 4, 5, 6, comma 2. So if you pass a decimal to round off, and this is the precision that we define. So we're saying SQL to round this decimal to this precision. Basically, it just shortens the decimal points to 2. Right now it has 2.3456. It has 4 decimal point 3456. But when we say round off 2.3456 comma 2, it reduces the precision to 2, which means the output will be having 2 decimal points, which is 2.35. That's how round works. And then for seal, seal of 2.4563. This will rounds it up to, seal rounds it up and floor rounds it down. Right now we're using seal, so it rounds it up to 3, the next highest integer. So it rounds it up to next higher integer, and the floor rounds it down to next lowest integer. So it takes out the decimal points totally and rounds it up. So because this is seal, it rounds it up to 3. And if we copy this, same thing, and if we use floor here, it is the opposite to seal. So it rounds it up to the next, rounds it down to next lowest integer, 2. We use this to get rid of the decimal points. If you don't want the decimal points, we use seal or floor. And if you want to reduce the precision of a decimal point, we use round. Okay, we are done with these two, and we have absolute. Absolute just converts a negative integer to positive, which means do this ABS of let's do a mathematical expression here. Let's do 45 minus 75. What would be the actual output for this? Minus 30, right? But if we do absolute, it converts the negative value to positive, which means this prints positive 30 and not negative 30. And then for the power, select power of 3 to the power of 2. Is also a mathematical expression. We're just powering 3 with 2, which should be 3 times 3 is 6. 3 times 3 is 9. So the output should be 9. And then we have random. Random just generates a random decimal point number in the range of 0 to 1. So this should generate a random decimal number in the range of 0 to 1. Whenever you run this, the random number changes. You see that? Changes every time you run it. It gives you a different random decimal number in the range of 0 to 1. That's it. We're done with these two as well. And for the next set of functions, which are datetime functions, let's do that. Select. First one, we already used it. Remember, we used current date, which returns current date. Current date. Today's 6th of November 2025. We already used it when we created the tables, but this is just for the demonstration. Yes, it returns today's date, like it says. We're done with that. Age calculates difference between two dates. So it calculates difference between two given dates. Please select the current date, the difference between current date and I'm going to give a date to calculate 11, 1. So I gave it 1st of November and the current date, say age at the beginning. So now it calculates the difference between these two dates, which will be 5 days. 5 days. Can be anything. If you change the year here, it says 1 year. If you say 2026, it says, oh, it also says month. $11 months, 25 days. Just calculate the difference between the given dates. And then we have extract. Get part of a date, year, month, or day. Select, extract. Year from current date. Now this extracts just the year from the current date, which will be 2025. That's how it works. And next one is now. Gives a current timestamp. That's it. With the time zone at the end. Is the time zone plus 5030. I mean plus 530. Oh, 530. Okay. That's the current timestamp. Then we have date truncate. We know table truncate, but date truncate is something similar, but with the dates. Truncates to the units, whatever you specify. Date truncate day current date. So this will truncate everything up to the date. Let's see. So it removes everything till the date. And if you say month here, it removes everything till the month. You see? And if it's a date or month, it replaces everything with 1. If it is time, it says 0. So it replaces, it removes everything to the desired measure. Okay, that is how date truncate works. With that, we're done with our demonstration, our third demonstration as well. By the way, if you don't know, I said download file name commands demo 3 because when you reach this checkpoint, when you go through the PowerPoint presentation, the slides, I name the files, these, whatever the queries that I run here. These files will be saved as .sql files and sent to you with the names commands demo, and the numbers represents the checkpoints, right? So you can download those SQL files and use them for your practice. Okay. Next one. We headed to subqueries. A subquery is nothing but a query inside a query. Till now, we just worked with the queries, right? This is just one single query. But now, the subquery means a query inside another query. And these subqueries are divided into 3 types. Inline subquery is a subquery that returns a single value, and a correlated subquery which references the columns from outer query, and derived table acts as virtual table in from. For the first example, let me just select products table for this. Okay. First, for the inline subquery, product ID, product name. Now let's write another subquery inside this query. So we are using 2 selects in just one single query. E-commerce. Don't need e-commerce, we just say products here. Products. As. Use as to alias with a name. The name would be total products. From products. So we're saying SQL to select product ID, which is this one, and product name, which is this one, and also select this total products, which is select count of product ID from products. So it selects the whole product ID count, which is 4, right? So it basically selects a total product count as another column, and then print it. Now the output would be this, and it says the total products as a separate column. We cannot do this without a subquery. If you take a good look at it, you might think we can do this without subquery just by writing count of products right here, but that is not possible because, let me show you the error as well. See that? Because this count of product ID is an aggregated function, and we are selecting a table. An aggregated function cannot be combined with the table. Like I said, the rule of the thumb, it should be the thumb rule. It should be either in aggregated it should be either aggregated or should be in group by. When we aggregate some column, aggregate any column, the rest of the column should be in group by or should be in aggregated, just like this. And that's what the error also says, right? Yeah, right here. The column product ID must appear in the group by clause or be used in an aggregated function. That's the rule of thumb. So we cannot use this, but by using subquery, we can do that with this, and this will execute. That's how we use subqueries. I mean the inline subquery. Now heading to correlated subquery. For this, we're going to use categories table. Categories. Right now we only have 2 rows. Okay. Here we got a new concept here. All right, this till now we just used the table name, but we haven't used the table alias name, alias alphabet. From here we're going to use this as well. When we define a table name, we can define an alias name. So whenever we want to refer to that table name, we can just say C instead of categories. That's how we say that's how we define the alias here. So we say from categories C, and whenever we want to use categories, we instead use C dot category ID. Instead of using categories dot category ID, we use C. Same with the products here. When we introduce the table, the query, we say P with a space in between. So we are aliasing product table with P. Now, whenever we use product table to refer to the table, we can use P. And coming to the core concept, the correlated subqueries references columns from outer query. And here we are selecting category name and category ID from categories table where exist. Here we use where clause, but the condition is quite different. We just use exist, which means it should just exist, like it says. So there should be something exists in that condition. So here we say select one from products P where C.category. So this C.category ID, we're referencing this column from out of this block of query, from outer query, from here. We're referencing categories table from outer query. And that's why it says references column from outer query. And we're referencing it using C.category ID equals P.category ID. And P.price equals 20. This prints this should be greater than greater than 20. When we run this, those electronics. So basically this query is, let me open the products table too so it's more clear for you. So this query basically checks. We are combining the products table as well here to check if which category has a product that has price over 20. And here the categories that has price over 20 are these two, and these two products belong to electronics category, and that's why only electronics got printed here. If you say less than 20, the other category will be printed, which is home and kitchen, because these are the only two products with less than $20 as price, and they both belong to home and kitchen category. That's how it works. Now we're done with correlated and inline. The next one is derived tables. We select all. Use group by category. Now if you run this, it'll be strict. So here we're selecting everything from the category instead of writing category name and category ID, because category table has only 2 columns anyway, so we don't have to write these two separately. So I selected everything from, and I'm not selecting everything from the table, but I'm selecting from this, this select. I'm selecting from a select, and that's what it says. Acts as virtual table in from, right? Inside, so this is acting like a table inside from, right? And here it is selecting categories, sum of price as total from products, group by category as T, and where total is greater than 20. So the total of the categorical price should be greater than 20. And when we see the products, when we add these two products, which belongs to same category, home and kitchen, the total comes to $12.99. When we add the products that belongs to electronics, the total comes to what? $105. And only the category which has a total greater than 20 should be printed. That means the home and kitchen will be taken out and only the electronics will be printed. And that's how it is printed. That is how derived table work. Derived table work as a table inside the from. We're not going to refer any table, but we're referring a select, a subquery, and the subquery is acting as a table. I know it is kind of hard, but these things will be easier for you if you work and if you have this foundation, all these foundational concepts. If you're so good at this foundational concept, these concepts should be easier for you. Well, it takes time. I know this is a speed run, so I'm going to write the queries as well. I'm going to write the queries fast as well. I'm not going to record myself writing the query because that eats the time. I'm going to copy paste the queries because I already had these queries, the example queries. So I'm going to copy paste them from now on to save the time because the queries will be bigger as we go. We have joins, and the types of joins includes inner join, left join, right join, full join, and cross join. Inner join returns only matching rows between two tables, and left join, all these joins are used to join two tables. The basic concept of joins is to, combine two tables, but there are a few types when we join these tables. Inner join only returns the matching rows between both tables, and left join returns all the rows from the left table plus matching ones from the right. And the right join returns the opposite to left join, returns all the rows from right table plus matching rows from left table. And the full join returns all the rows from the tables. So if you don't want to lose any data, we use full join. We have cross join, is a Cartesian product. It returns every possible combination. So we'll see example for all these 5 joins right now. And by the way, like I said, I already copy pasted all the queries that we need for the joins, so we don't waste any time and we get right into the explanation of the queries. So here we're going to select the customer's query, the customers table, run that. And for the first one, for the inner join, we have this. Here we're selecting order ID, first name as customer name. We're just aliasing it like we saw before, and the quantity from which table? Orders table, by the way. Select all this from orders table, inner join, customers table. Here we're referencing 2 tables at the same time, right? So when we reference, when we want to join the tables and then reference the data out of it, we use joins here. And we're joining orders table with customers table. We have to define the condition on which we need to join these 2 tables. Here we're joining these 2 tables on condition customer ID equals to customer ID in orders equals to customer ID in customers, because those are the only 2 common columns in both the tables, right? And yes, we're joining these 2 tables and then we're selecting order ID, first name, customer name, and quantity. If you take a look at these both tables, customers and the orders table, I'm going to run that in a separate tab. Yep. Here, orders consist of second, the customer ID 2, 3, and another 2, 4, and 5. So we only have 4 customers in the order who actually ordered. But in the customers, we have a total of 5 customers, which means one of the customers haven't ordered any. So he will be taken out because he's the only person that is not matching when we join inner join. So he will be taken out. And which customer is that? That customer is customer number 6. So Nova will be taken out and the rest of the customers will be printed. Now let's print the query in a new tab. Like I said, we have Kate, Raj, Kate again, Liam, Sophia, but Nova is taken out because he haven't ordered any. That's how we use this. And next we have right join with the same example, but with right join, which means Nova will also be included in this output. Let's have that. and run that in a separate tab again. Here, this is the inner join output, and this is the left join output. No, right join output, sorry. So this returns all the rows from the right table plus the matching ones on the left. So it returns all the tables and all the rows in the right table. And the right hand side table is customers. So it returns every customer, even if he haven't ordered any. So Nova is also included here, but the order ID is null because he ordered nothing, and the quantity is also null. That's how right join works, and the left join is quite opposite to it, so we're not going to do that. And for the full join, it should be the same output. The full join also is the same output. It includes everything. And we have cross join. This doesn't have a context, but I'm running this just to show how it works. All right. So when we run cross join, it returns every possible combination to that customer. So if we run this, there you go. So every possible combination for every customer is taken. So we get 24 records. That's how cross join works. There is a very rare possibility of using cross join, but it is better to have knowledge on it. It is good to have knowledge on it. Okay, that is it with the joins. Heading to set operators. Set operators treat query results as mathematical sets, and the sets or set operators divided into 4 categories: union, all, intersect, except. If you remember, we have these set operators in mathematics. These act exactly like that. So let's dive right into the examples. For the first one, we also have a question here. Show all unique customer IDs that appear either in orders or in customers. For that, we obviously use union because we need the customer that appear both in orders and customers, right? So this is the right one. Combines results and removes duplicates. So when we run this, 2, 3, 4, 5, 6. And the union all is same like union, but this also includes the duplicates in it. There you go. So it gives 2, 3, 2, 4, 5, 2, 3. Because in orders, these 5 customers are repeated in orders table, right? Here, these 5 customers are repeated in orders table. Here, we have 6 customers. No, I think I messed up. Now, we have 5 customers in the customer table, and we have 4 customers in this orders table, where union takes out duplicates, but union all includes the duplicates as well. So we get five customer IDs from here and 5 customer IDs from this table. So we get total of 10 records as output. And then we have intersect. Intersect returns only records common to both sets, which means it should only print 2, 3, 4, 5, and it should avoid the 6th customer ID. Let's run that and see. No, not union all, intersect. You see that 4, 2, 3, 5, and the 6th customer ID is avoided. Then we have except. Find customer who registered but not placed any order. Returns records from first set, not the second set. Not in the second set. So it only returns the customer IDs that are in the customers table but should not be in the orders table, which means 6 is the only customer ID that is in the customer table and not in the orders table. There you go. That is how set operators work. With that, we're done with our fourth demonstration. Heading to fifth. Now, common table expressions. This is an important topic too, but you might feel difficult to understand it because you are a beginner. But if you practice more on the topics that we discussed prior to this slide, you will find this easier as well. But because this is a speed run, I have to move faster. But if you want a detailed SQL explanation, full course, comment in the comment box. If I got more requests, I'm going to do a full detailed SQL full course videos. I don't think I can do that all at once. I have to release 2 videos per week. So in that way, I explain every single topic, elongated. That makes it a lot easier than a speed run. But I try my best to explain all these topics. Okay. The common table expressions is a temporary named result set defined with a SQL query used in with clause. It basically acts like a temporary table in a transaction. And we use this when we deal with complex algorithms, complex situations, we use CTEs. And this is the syntax for a regular CTE, and this is for a nested CTE. Not nested, I would say multiple CTEs. So these are the syntax for that. Here's an example and a question too. Find the total amount each customer has spent on their orders. To do that, we're going to create a CTE using with, and we name the CTE as customer spending and we give the query logic here, and we define the query logic that this CTE should have, which includes select customer ID from orders table and sum of price times quantity as total spent, and then from orders join products, which is, we use inner join here, by the way, and on the condition orders product ID equals products product ID grouped by customer ID. From this common table expression, we refer first name, last name, and total spent from customer spending. This is our CTE that we just created. Then join customers with that CTE on the condition CS customer ID, C dot customer ID, order by total spend in descending. So the one with the highest spend will be on the top. And when we run this, we should see all the customers with their total spend in descending order, which means the highest spend customer is on the top and followed by the lowest spend. Okay, that is how we do it. I know you might feel hard to comprehend this logic, but it takes time, but it will work. And here in this query, we use 2 CTEs. And the question is, first calculate total spending per customer, then find customers who spend more than $100. Here we say with customer spending and CTE name as, this is the CTE definition, select customer ID, price quantity, just like the top. We select the customer ID and the price times quantity, which is the total spent, and group by the customer ID. And then we have high value customer, another CTE, select customer ID, total spent from customer spending. We are referring to this CTE to create another CTE, and where total spend is greater than 100. So this CTE only has the customers that are spent over $100. Then we select first name, last name, and total spend from that high value customers only, which means this should take out all these 3 customers and only print Kate, because Kate is the only one who spent more than $100. Let's run that. There you go. So we're done with the CTEs. And with the window functions, we have window function perform calculations across a set of rows related to the current row. Syntax is this. We'll start with a function name, can be row number, rank, dense rank, any of them, and expression over partition by and order by. Functions include row number, rank, dense rank, lag, lead, entile, sum. Okay, let's see examples for each and every one of them. The first one, the question we have here is, write a query to assign a unique row number to each order, sorted by order date. So we're just assigning a row number for each order, that's it. Just simple as that. And we're selecting order ID, customer ID, order date. We are using row number with the just as the syntax mentioned. Function name and expression over and order by order date. So we're ordering by order date and as row number from orders. There you go. We're just numbering the rows. That's it. That is simple. So we're not going to waste much time on it. And the next one is rank. Rank customers by their total spending, allowing gaps in ranks for ties. There is a small change, a small difference for rank and dense rank, and I'm going to demonstrate them. Okay, for now we're just ranking the customers based on their total spending. Select customer ID, sum of price at times quantity, rank over order by sum of the total spent. The total spent, and it should be in descending order and as rank position. When we run that, you'll see the ranks here, right? And now the difference between rank and dense rank, we're using the same example. You take a look, but here we're using dense rank. Now we'll see the difference between rank and dense rank here. I'm going to run that in a separate tab here. What is the difference between these two? What is the difference between these two? In the normal rank, like it says, assign a rank, ties get the same rank, next rank is skipped. Here, these two have the same value, same total spent, 51, 51, right? So they both get the same rank, second rank. But the next rank will be skipped in the rank function. Like it says, the next rank is skipped. So the next rank is skipped, the third rank is skipped, and it right away goes to fourth rank. That's how rank works, but the dense rank doesn't skip the tied rank here. Even the both customers have 51, 51, and they both have the same rank, but the next rank, 3, will not be skipped, but assigned to the next person. That's the difference between rank and dense rank. All right. Okay, now we go to lag. Now we go to lag. Accesses previous rows values. Let me show you. Let me run this. Here, the question is, compare each order's quantity with the previous order's quantity by date. So it selects order ID, quantity, and lag quantity by 1 over order by order date as previous quantity from e-commerce orders. Here, we are creating a separate column for previous quantities too, which means every order has a previous quantity. So for the first quantity, there will be null because there is no previous order, but for the second order, there is a previous quantity, which is 1, will be assigned to the previous quantity in the next row, and that row's quantity will be assigned to the previous quantity of the next row, which is order ID 4, and the previous quantity is 4. That's how lag works, and the lead works quite opposite to lag. Let me show you the lead example, which accesses the next row's value, not the previous row's value. Here's the example. And we have n-tile, divide result into n equal parts. Divide customers into 3 spending tiers. 1 is the highest spending. And when we run this, so when we are dividing these customers into 3 equal parts, right? No, 2 equal parts. Here we define n-tile as 2. So we are dividing the customers into 2 equal parts according to the spendings. So the 1 is the one who's the spending tier 1 is the one who spends more, and the spending tier 2 is the one who spends less. We are splitting them into 2 equal parts. That's why we have 1 for these 2 and 2 for these 2. We're splitting them. Then next we have sum, average, and count. For each order, show the total, average, and count of quantities per customer. When we run that, here we selected customer ID, order ID, quantity, and sum of quantity, and average of quantity, count of quantity over partition by customer ID, total orders. So it sums everything by the customer ID. So it is partitioning by customer ID. So only the customer ID for this row, only the customer ID with 2 orders will be summed together. So for this, the customer ID 2 orders ordered twice, right? So the order quantity will be summed up, which means in this order they ordered 1 quantity, and this order they ordered 3 products. So these 2 will be added together and assigned it to total orders quantity 4. And same like that, we have average. Instead of adding them, we are averaging them, and average for 1 and 3 is 2, and average will be assigned to average order quantity. And for the order count, it counts the orders, and customer ID 2 ordered twice, so the order count will be 2. That's how the count window function works. Okay, we're done with the window functions as well. Means we're done with the demonstration 5, heading to demonstration 6. Till now, we just worked with the tables, select queries, right? We haven't worked with views or materialized views. Now we are going to work with them. The definition for that is both views and materialized views are virtual tables based on queries, but they differ in how data is stored and refreshed. View is basically, I think I already explained a view. What is a view, right? You just create a view. So, view acts as a table, but it doesn't store the actual data physically, but it refers to a source table. We will see what it actually means exactly. Here, we're creating a view. The question is, create a view that shows each customer's total amount spent. And we create a view using this command, create view, and this is the view name. Select customer ID, first name, sum of price times quantity as total price. And we join customer, orders, and products, grouping by customer ID and first name. Rule of thumb, which every column that is selected should be either in group by or in sum of, in aggregation. Okay, when we run this, now we created a view. Right now we only have tables. We only have tables, and we have 4 tables. We haven't created any views yet. Now we did create it. So we refresh this views. Now we will see the view. And the views are stored under the views folder, and the tables are under the tables folder. These are the views. Like I said, these are not physical entities. They are just queries, but act as a table. The data is not stored in the view, but it refers to a source table. In this case, it refers to these 3 source tables: customers, orders, products. So whenever we refer to this view, it goes back to those tables to ask the data. The good thing about a view is it is always up to date. Whenever you change a column or row in these tables, the data in the view automatically updates. You don't need to update the view again. You just need to no, you don't need to do anything. The data in a view will be updated automatically. Whereas in materialized view, it stores the data physically, just like the table, but like a snapshot, like a smaller version of a table. Materialized view saves the data physically, but it still refers to a table, a source table. Let me show you an example, by the way. I cannot just say it. It's harder to explain. So this is the materialized view. I'm creating the same logic, the same view, but I'm creating it as a materialized view. Same query, but materialized view. I'm going to create that. If I refresh materialized views, I should be see the view listed here. Now, this is also a view, but this stores the data in it. It still refers the data from the table, but whenever you want to access any data from this view, you don't go back to the table to access the data. It just gives you the data right away, which makes it faster. But whereas view is slower than a table, but materialized view is faster than view, but it needs to be refreshed whenever you want to access it. And refreshing a materialized view can be done with this command: refresh materialized view and the materialized view name. Here we just created a materialized view, right? And we also created a view. This is the view. When we query this view, it goes back to the source. Here the sources are customers, orders, and products. It goes back to the source to get the data. But when we query this materialized view, it won't go back to the source tables, but it stores the data by itself, so it is relatively faster than view. The only difference here is if you update anything in the materialized view, not in the materialized view, in the source table, the materialized view will not get updated. Okay. To compare these materialized view and view, I'm going to show you an example here. So if you take a good look at this, I'm going to update the orders table. All right. I'm going to update the orders table. Right now, we have total spent as 51, 118, 51, 96 for the materialized view. Let me run this as well, so I can show you the before and after results. So before, they both are equal, they both are same. Now, when I update the orders table, which is the source for these two views, when I update the orders table, all right? Okay, whatever. When I update the orders table, And now when I reference the view, it automatically gets updated. You see that? Updated an order for Kate, and the total spent is automatically updated because this is a view. Whereas this used to be the old total spent. Okay. This used to be the old total spent. This is the new one. The view automatically updated when the source updated, right? But when we query the materialized view, it will not be updated automatically. Let me show you. You see that? I did run it, but still the Kate has the total spent as $118, which is the old version, so it is not updated yet. So to update the materialized view, you have to run refresh every single time you want to refresh it. So now it is refreshed, and now when you query that view, now it is updated. That's the difference between materialized view, table, and view. View updates automatically when the source updates, but materialized view doesn't update by itself. But the advantage of materialized view is it is faster than view. That's it. And the downside for materialized view is it has to be refreshed when the source is refreshed. Source is changed. Okay, that's how it works. Tried my best to explain it. Now, stored procedures and functions. From here, we are stepping into some advanced topics, all right? This might be harder for you to understand, but I'll try to explain it, okay? For the functions, we have a question. Create a function that takes product ID. First, let me define the function. For the function, the definition is functions return values and can be used inside queries. Procedures execute operations, insert, update, delete, but cannot return a value. If you work with any other programming language, we use functions, right? You know function. We create function to reuse that logic on different data. Whereas procedures doesn't return anything, but it executes operations like insert, update, or delete. And it has two syntaxes. This is the main creation syntax, and this is the calling syntax for functions, and this is the procedure creation syntax and calling syntax. Okay, our first example, create a function that takes product ID and quantity ID as input and calculate the total price and returns total price and returns it. Okay, now we're creating a function that can be reusable, which means it can be reusable with any values we are sending it, and it returns the output to it. Here's how it goes. Like the syntax says, create or replace function, and the function name is fn calculate total. There is in, out, in, out in the function input methods, where in is a variable that we define as an input, and out is a variable that we define as an output, which returns the value. Here, use as to begin a function. Here are these two dollar symbols to begin a function, and here, no, sorry, I messed up. Use these two dollar symbols when we write anything in the language PLPGSQL. PLPGSQL stands for Procedural Language PostgreSQL. We begin the function, we select price times quantity into total price from e-commerce products, where product ID is equals product ID. P underscore product ID, and this one, where P underscore quantity is the quantity that we pass, and p underscore product ID is the product ID that we pass. And here it calculates price time the quantity that we sent, and then it selects only the product IDs which we give, which we pass, and then calculates it and returns the output, which is total price. And to call this function, we use select and the function name and the parenthesis, which has the arguments in it. Now I'm sending. Let me just first create the function first, and then so I created the function now. And now when we call the function using these two arguments, it gives the output, which is 77.97. So this function calculates total price for that particular product ID. So we give the product that we want and the quantity of the product, and this function calculates the total price that costs for that product with this quantity. I don't know how to explain it, but I'm trying my best. Yes, here we sent 1 as product ID and 3 as quantity. For the first, for 1 as product ID, we have what? We have all from products. Okay, for 1 as product ID, we have wireless mouse, which is worth $25.99. The quantity is 3. So 3 times $25.99 is 77.97. That's what happened here. And we have another input format which a variable can be defined as in-out. So the variable is input, both input and the output. So it acts like both input and output here, and this variable discount percent is input. And the question is, create a function that takes price and discount percent as input and calculates the final price and returns it. Now it takes the price and the discount percent and it calculates price, and this is the assignment operator, by the way. Colon followed by equals to is an assignment operator, so this calculated output is assigned to price variable. Price equals price minus price times discount percent divided by 100, and it discounts the price and gives the final price as an output. So let's create it and try running it. So I gave 100 as the price and 10 as the discount, which means 10% discount for a product worth 100 should be 90. The answer is 90. So the stored function, the functions work, and now for the procedures. So the procedures doesn't return any value, but it executes the operations like insert, update, and delete, right? Okay, here we are creating the procedure. This is syntax: create or replace procedure and the procedure name. Update price by category. These are the variables defined, and both are defined as inputs. Okay, so because this doesn't have output, right? So we're sending the inputs with these two variables defined into the language. I mean the function. Here it begins update e-commerce.products, set price equals price plus price time p% by 100, and where category equals p category. Price notice just notices with an output, of this price updated for category, percent, and the category name. This call the procedural language. So the syntax for to call procedural language and the syntax for to call function is quite different. In the function we use select, and in the procedural language we use call. Call followed by the procedure name, and then we send the arguments. Now when we run this, the output says price updated because we used rise notice here. The price updated for category. The category name is P category, and that's it. Yeah, that's the output. And our next procedure is this. Sorry. We don't have any next procedure. Our next slide, exception handling, works only inside PL/PG/SQL blocks, typically in function or stored procedures. So let's say you don't want to get any exceptions like division by zero exception or unique violation or foreign key. So if your logic or if your query triggers an exception, instead of exception, you would do some sort of, what to say, you can define an action if this particular exception triggers. In this case, we are using when, and the exception here is division by zero. So when a division by zero exception occurs, raises notice and says division by zero occurred, returning original price. This avoids getting errors as outputs. Instead, we get the raise notice and it returns to the original price. So now let's run this. This is just a function, by the way. And in this function, we just divide the price with the partition. And we run this. Because we are dividing it by zero, the exception triggers, but we don't get the error as output. Instead, we get the actual price as output. So instead of zero, if we do anything else, or one, divides it. Because it is zero, we cannot divide it. So the division by zero exception occurs, and it raises the notice, and it leaves the function. Okay, with that, our demonstration 6 is also completed. That is our last demonstration. And by the way, these are the exercise questions that you can practice. I crafted 10 exercise questions, and the answers for these exercise questions will be also given in a .sql file, and the link for that file will be in the description. Yes, these exercises, starting from 1 to 10, it goes from easy difficulty to hard difficulty. So you can practice with these exercise questions if you're good with SQL and you watched the whole video. Well, I tried my best to explain everything. Because this is a speed run, I don't have much time to explain everything in particular. So I tried my best to make it clear. But if you want a clear and detailed explanation about SQL, don't forget to ask me. I will try to do a detailed explanation about SQL, but it takes months, I think, to create a detailed explanation, but I will do it. With that, our SQL full course speedrun is officially completed. If you at least get some sort of knowledge out of this, I'd be so glad. Yeah, I'll try to make another video building an SQL warehouse with the concept that we used in this course. Until then, take care. See you. Bye-bye.